Okay, today we're going to talk about using linear systems to solve problems, which in other words is word problems. For each of the following problems, we want to clearly define your variables, write a systems of equations that model a situation. I am not at this time going to ask you to solve the system because we've been practicing how to solve systems. Okay, for this first problem, the drama club at Lincoln High School sells hot chocolate and coffee at the school's football games to make money for a special trip. At one game, they sold $200 worth of drinks and used 295 cups. If hot chocolate sells for 75 cents and coffee sells for 50 cents, how many coffees did they sell? So when I read this, they're talking about two situations. So this is going to be a two-variable solution. So the first thing we're going to do is to clearly define our variables. I use X and Y most of the time, so I am going to make X equal the number of hot chocolates sold, and Y is going to be the number of coffees sold. Now, when I'm doing word problems, especially with systems, I'm going to first look for totals, then a comparison. And so when I read this, I'm reading that they are telling us that it has sold $200 worth. That's a total in that one game. And this is how many cups they sold, which tells me how many total coffees and chocolates they sold. So I know one equation is going to be with the numbers, and one equation is going to represent the money. So starting with the numbers, I know if X is the number of hot chocolates and Y is the number of coffees, and the total number they sold is 295. Now the next total is money, so I'm going to put the money in front. So if hot chocolate sells for 75 cents a cup and coffee sells for 50 cents a cup, they have a total of $200, and there's your system of equations. Okay, this next one, Catherine is deciding which catering company she should use for a birthday party. One company has a fee of $10.25 and a charge of $9 per person. Another company, there's a fee of $49.25 and a charge of $6 per person. How many people will make each the same cost? What does that equal cost? Well, we're not solving it, but that tells me how many people is what X stands for. So X is going to be the number of people. So that's my first definition. X is the number of people. Well, the other comparison is totals. We don't have any totals, but we have situations for each company. So I know that Y is going to equal the total cost. So my two equations are going to be each company separately. So one company's total cost is equal to the $10.25 flat fee plus $9 per person, and people are X. And the next company is the total cost is $49.25 plus $6 per person. Now, when we solve this, we'll find out when these two companies are the same, and then you would determine which company you would go with by which direction that cross is going. Okay, 17 cars and trucks get gasoline at the gas station. Each car gets 12 gallons of gas, and each truck gets 22 gallons, and the total cost is $294. What is the number of trucks? What is the number of cars? So they're telling me right there what X and Y is. X is the number of trucks. Y is the number of cars. Well, they're telling me that 17 cars and trucks get gasoline, and the total cost is $294. So again, I'm going to have an equation that has to do with the numbers of cars and trucks together and the total cost together. So one equation is the number of trucks plus the number of cars equals the total number of vehicles that get gas. And then the next one is cost per gallon. So I get, or how many gallons each gets. So a car has 12 gallons and a truck holds 22 gallons. And total, that's $294. And there's your system of equations. Okay, Callie's Dress Shop sold cheaper dresses for $90 each and more expensive dresses for $140 each. They took in a total of $5,250 and sold 20 more of the cheaper dresses than the expensive dresses. That's a comparison. So this word problem is giving me a total amount. So I'm going to write one equation that is equal to that total amount. Now this one is 20 more of the cheaper dresses than the expensive dresses. We'll talk about that one in a minute. So X, the question is how many of each kind did they sell? So X is going to be the number of cheaper dresses, and Y is going to be the number of the more expensive dresses. Now I'm going to get that total out of the way because the total is money. So I know it's $90 for the cheaper plus $140 for the more expensive equals that total. So I get that one out of the way. Now this is the one that you've got to think about how you want to set it up. 20 more the cheaper dresses than the expensive dresses. So I've got cheap and expensive. When I read that statement, there is more cheaper. They are bigger. So I can adjust cheaper to make it equal to the expensive, or I can add the difference to the expensive. That's what I tend to do. So the cheaper is X. So X is equal to the more expensive, which is Y, plus 20. So if I add 20 to the more expensive, they're now equal in number. And that's sometimes the hardest one to write. Okay, for this problem, a student written performance is playing at the local high school. Rachel paid $52 for 2 adult, 2 student, and 1 child. RJ paid $56 for 1 adult, 2 children, and 3 child. And Anna paid $44 for 1 adult and 4 children. Now it says choose the best answer. This is an SAT practice problem. And we're going to use A for adult, S for student, C for child. And the question here is which equation is not a part of this system. So I can see the $56 and 56 here. And it's an adult, 2 student, and 3 children. And then Rachel's 52, and that's 2 adult, 2 student, 1 child, so that one works. And Anna's 44, and that is 1 adult and 4 children. So, yep, that is the one. So D is not part of this system. Now we want to solve and find out for each the price for each ticket. So X would be the price of an adult, Y would be the price of a student, and C would be the price of a child. That would be our definition. And now I'm just going to use my matrix technology to solve this one. So remember, it would be each of the coefficients of each of the system, and my system is right here. So a 2 for A, a 2 for S, a 1 for C, and the total 52. A 1 for A, a 2 for student, a 3 for child, 56. And then 1 for adult, there are no students, and 4 children for 44. Put that in our calculator, and it will give us B as the solution. Okay, last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. There's a total. And the proceeds, that means the money, totaled that. So there's 2 totals. Tickets can be bought one of 3 ways. I've gotten a matinee, a student, and a regular admission. How many of each type of tickets were sold if twice as many student tickets were sold as matinee tickets? There's a comparison. So I have two equations that are totals and one equation that's a comparison. So definition, I am going to do X equals the number of matinee tickets. Y is the number of student tickets. And Z is the number of regular tickets. Okay, so total numbers of tickets. So matinee plus student plus regular equal that total number of 8,500 tickets. The next total is money, so let's put money in front of each. So the matinee costs $5 each. The student is $6 each. And the regular is $8.50 each. And that total amount was $64,600. So there's my two totals. Now again, the comparisons are the hard ones. So they're comparing student, which is Y, and matinee, which is X. Twice as many student tickets, so students were the larger value, as matinee. So twice means two times. So to make them equal, I'm going to make my matinee, I'm going to do the math to the matinee. So the student tickets equals 2 times the matinee, because now they're equal, because I had to multiply that matinee by 2. Okay, Tasty Bakery sells 3 kinds of muffins. Chocolate chip muffins at 40 cents each, oatmeal muffins at 45 cents each, and cranberry muffins at 50 cents each. Charles buys some of each kind and chooses 3 times as many cranberry muffins as chocolate chip. Oh, well, there's my comparison, so I need to make sure I keep track of that. 3 times as many cranberry as chocolate chip. If he spends this, that's a total. He spends $7.90, which is total, on 17 muffins. How many chocolate chip muffins did he buy? So the ultimate question is just going to be to find chocolate chip. But we're going to write this system. So let's make X equal the number of chocolate chip muffins. Y equals the number of oatmeal muffins, and Z equals the number of cranberry muffins. I'm going to get the two totals out of the way because those are the easiest ones to write. Total money, so that means I'm going to put money in front. So 40 cents for chocolate chip plus 45 cents for oatmeal plus 50 cents for the cranberry, and the total is $7.95. These were cheap. Then the total number is 17, so the chocolate chip and the oatmeal and the cranberry are 17 total muffins. Now, 3 times as many cranberry as chocolate chip. Cranberry has more, so we're going to do the math to the chocolate chip and multiply it by 3. So cranberry equals 3 times the chocolate chip. Now they're equal to each other. Okay, last one for today. John inherited $25,000, invested part of it in a money market account, part of it in municipal bonds, and part of it in mutual fund. After 1 year, he received a total, so they're telling me a total, we got to pay attention, total of that and interest from the 3 investments. And then it tells me the money market paid 6%, the bonds paid 7%, and the mutual fund paid 8%. There was $6,000 more invested in the bonds than the mutual funds. Find the amount John invested in each category. So I see a total of investment, but that $25,000 is the total money he had to invest overall. So let's make X equals the money in the money market. Y equals the money in the bonds. And Z equals the money in the mutual funds. So I'm going to write the total of money he had. So money plus money plus money equals total money. The next total has to do with their interest, which is based on their percent. So 6% for the money market, 7% for the bonds, and 8%, oops, I didn't write that correctly, did I? And 8% in the mutual funds, and the total was $1,620. Now, $6,000 more invested in the bonds than in the mutual, which is Z. More money here, so we do the math to the Z. So Y equals Z plus $6,000 more, and there's your system.